All right, guys, welcome to another episode of Cuda Education. Today, I want to go over the changes that were made in the ray tracing basic script. There is an article that the author of the script, Sascha Willems, made talking about the improvements he made to code for all his samples that he has, and we've been working our way through. So for this particular script, basically it's just generating a ray traced triangle, right? Both the old and the new do the exact same thing, but it's how it's being done that is always the kicker, right? One is more efficient than the other. One has less synchronization bottlenecks, and one is more straightforward and the other one is not. So the old is the old one and the new is the new one, right? Pretty straightforward, as you can see. 2019 to 2023, 2019 to 2025. So the new one has some improvements. I simply want in this video to kind of just browse the differences between the two files in in this video. I just want to see what has changed. There's a lot of implicit things that's going on, and I need more time to really investigate them. Also, um, for me personally, especially with this script, because this script is the most basic ray tracing example of all the examples in the solution. This is the most basic ray tracing example. One of the big things that I wanted to clear up for myself was the command buffer, right? Because the command buffer was, even though it's a very simple concept and straightforward concept, in the old script um, it was a little bit like convoluted, but I couldn't really at the time. I was very very new to Vulkan, and I couldn't really um, verbalize why I didn't understand the logic for the command buffer, right? um, since the article, Sasha came out with an article that sort of explained a lot of things, and I've been trying to really fully understand all that he's saying. It's a very well written article. I will link it in the description below. But as far as the article is concerned, one of the things was cleaning up syncing. So as it relates to the command buffer, in the old script, all the command buffers for the frames was pre-recorded, or it was you basically did a for loop and you pre-recorded all the command buffers at once. In the new script, you basically do one command buffer per frame, and it's more straightforward. It's more it's just more easier to manage the logic and the instructions and the syncing and all that stuff. So for me, it was the command buffer. But yeah, so you know the command buffer syncing, command buffer for me, but implicitly with that issue, it's the syncing, right? And just making things a lot more um straightforward. Now, to be fair, when Sascha Willems initially created these examples, Vulkan was still relatively new. Vulkan is still new. I mean, it's still considered a very new language, but at the time, there were no best practices. There were no, there wasn't any sort of lived sort of experience with the API, and sort of, you know, routines and understood best practices for the API. Now in 2025, or since he wrote those examples, there is. So you kind of have to you kind of have to be fair and understand where he's coming from, as to why things may have been a little bit more convoluted before, and they're a little bit straightforward here. Um, as I said, I still need time to do my investigations on this stuff. So I'll try to not say too much. Um, the only thing I will say is that a lot of the synchronization is done in the base class. So this is the script for ray tracing basic, the .cpp file, but a lot of things are being referenced or being used from the base class, and the actual syncing, the fencing, and the semaphores and all that stuff is actually from the base class. So you're not really going to see explicit like syncing logic in this file, right? Um, because a lot of it, like especially on the old file, a lot of it was deferred to the base class and all of that, right? But I need some time to sort of flesh out what exactly, all of that means. But either way, I think it's a good practice for all of us that are learning Vulkan or trying to learn Vulkan to understand, um, to just basically review the changes that were made, and really think about, you know, why the new script is better. The new script is on the right side, the old script is on the left side, right? Why the new script is better, and sort of just observe and think about, um you know the changes, and why they're done that way, and how it might be improved. But again, I'm trying, I'll try not to say too much, because I still need time to really um investigate the ramifications for all this stuff. So I'm gonna do a quick rundown of the two files, and we see what changes have been made. So first of all, of course, um, the copyright has been updated, right? Also, guys, if you want to join in on this these set of samples, and follow me on the journey, you need to get tutorial number 1, which is installing the Vulkan API, and tutorial number 13, which is installing all of these examples. Now, I assume a Windows-based machine. I assume a Vulkan-capable GPU. If you want to run the ray tracing examples, which this is a ray tracing example, you need to also make sure your GPU is ray tracing capable. For NVIDIA, that means RTX GPU or greater. If you're talking about other vendors, Intel, AMD, I can't help you with that. But I know for the NVIDIA cards, you need an RTX or later or greater card. Okay, Vulkan ray tracing capable. All right. So all right, let's just go through it and be done with this process. All right. So the copyright has been updated. Okay. Base class. Um, Now we have a null pointer reference. Okay. Here we have index count variable that's initialized. Now we have index count variable initialized with 0. Um, storage image, and then storage image like this. Okay. VKS buffer UBO, VKS buffer. Notice that we have this max concurrent frames. So we initially now we have an array. Before it was just a variable, now it's an array, right? Uniform buffers, UBO before, and uniform buffers now. All right. Um, we have these changes here. Again, we have our max concurrent frames. So this now, the descriptor sets is an array. It's not just a variable, now it's an array. Right? So we have the descriptor set here, but now we have it as an array. going all the way up to max concurrent frames. Okay. Yeah. All right, this is just good housekeeping, these constructor and all of that. Yeah, so now we have to destroy all of them because it's not just one variable. Okay, for the UBO. All right, everything else remains the same. All right, so here we have instances. Yeah, we have this reference to instances in the old file. In the new file, it has disappeared. Just like a magician. Okay, so now we're not doing instances here like that. We do have a buffer for instance data, instances buffer. Okay, so this stays the same. All right, notice that the instance reference here is a lot, it's a lot more straightforward. So the create buffer call, the instance reference is a lot more straightforward. 1 second. Okay, so primitive count is size of instances in the old one, and here we just have the number 1 for the new new iteration. Again, this is all in the create top level acceleration structure function. Top level acceleration contains the scene's object instances, right? So we're creating an instance of the triangle basically. Instances 1. Okay, create descriptor sets. I do know for the descriptor sets in the old file, you're sort of reusing the same descriptor set, and in the new file, you have a descriptor set for each frame. Like it's, every frame has its own sort of descriptor set, right? So here you notice that like pool size and everything, it's basically on the old file you just have 1, right? And on the new file you notice that it's associated with the max concurrent frames. So basically you're doing a descriptor set per frame, whereas in the old one you just have 1 descriptor set that you're reusing, and that's problematic because you have to shuffle between all of your frames to use this 1 descriptor set, or something to that logic, right? See, pool size is 1. pool size is max concurrent frames. So per frame we have, a descriptor set, right? Let's see, sets for the new one, it says sets per frame, just like the buffers themselves. Acceleration structure and storage image does not need to be duplicated per frame. We use the same for each descriptor to keep things simple. Sets per frame just like the buffers themselves. Okay, so you're setting the descriptor sets per frame just like the buffers themselves. Acceleration structure and storage image does not need to be duplicated per frame. We use the same for each descriptor to keep things simple. All right, I'm not in a position to dispute that claim, so we're just going to run that. In the old thing, what is this? Descriptor set allocate info. Um, okay, what is this? Okay, notice. Okay, so notice for the new file, we have this for loop, right? And we're basically creating a descriptor set for each frame. Descriptor set I, okay? In the old file, we're just doing one, basically, right? But in the new, we're going from 0 to max concurrent frames, right? And we're looping through I for that. And, so just appreciate that, here you're doing, we have a descriptor set here, but we have descriptor sets I for the new one, because we're looping through, we're making multiple descriptor sets. So the for loop for this one is basically saying, hey, we're creating multiple descriptor sets. Here it's just one straight descriptor set. But again, this is problematic because you have to share everything with that one descriptor set. And if, if it's being used by another process, you can't, for example, write or update it or read it for a new process, right? So, or if it's been updated somewhere, you can't read from it and all of that, right? So the synchronization piece of it is sort of like implicit or in the base class or whatever, but it slows things down when you have to reuse the same thing. Here in the new one, every frame has its personal descriptor set. All right, so we're good there. Um, um, you see, even for this result image write, uniform buffer write, even with all of that, you notice that it's driven by this descriptor sets I thing, whereas here you basically just push everything onto that one descriptor set variable, right? So two different things going on here. So that gives us some level of insight into how this works. Um, destination set. Yeah. And then we have our VK update descriptor sets. All right, so we'll move on from this block here, but you kind of get the idea. Um, Again, for the uniform buffers used to pass matrices to the ray tracing ray generation shader. Create the uniform buffer used to pass matrices to the create a uniform buffer used to pass matrices to the ray generation shader void. So here again we have a for loop. Um, but I'll leave that alone for now. Create buffer, create buffer. Yeah. So here we have update descriptor. Here we have update descriptors because it's multiple ones. Um, I just want to know where okay, so I is being used here. Okay, right descriptor set. See, we just have the descriptor set here, and then we have descriptor set I for this guy. If the window has been resized, this logic right here, if the window has been resized, we need to recreate the storage image and its descriptor. So notice that here we don't, for the resize here, we don't have a for loop. For the old one, we don't have a for loop. But for the new one, we have a for loop naturally because we have multiple descriptors, right? So that's that. All right, so here, command buffer generation. So now we're doing command buffer generation. Notice that for the old one, we are for looping over this draw command buffers variable, which I had problems sort of figuring out, when I was initially going through this stuff. But, we're pre-recording the command buffers, right? So we're doing it from 0 to the size of the draw command buffer variable, right? And we're pre-recording. Notice that here in the new thing, all of this is blank. However, we do a switcheroo. So notice here, we have stuff here and it's empty for the new one. In the next segment, we're empty for the old one and we have stuff in the new one. So I'm just gonna look at this first. So this is the old file with all of this command buffer logic where we're pre-recording all of the command buffer stuff, right? And then we're gonna jump to the new logic where in the old file there's nothing, but in the new file, void build command buffer, right? And here in the new logic, notice that everything is being driven by draw command buffer, current buffer, right? So this current buffer index um, basically tells us that we're doing a command buffer for the current situation, for the current frame, for the current thing, you know, but it's just one. Uh, we're not for looping anything or anything like that. We're just doing one thing, right, for this particular frame, right? Uh, right, so this command buffer is what, you know, what basically runs through all of this. And we fire off our ray tracing process, VKCMD, trace rays, KHR. We should know what this is by now, guys. Prepare swap chain image as transfer destination. So remember, in our swap chain, a swap chain is a lineup of frames that eventually, it's a queue of frames that eventually leads to presentation. But we have to slot out those frames, do stuff with it, and slot it back into the swap chain queue. So we slot out the frame, we draw something on the frame, and we slot it back into the swap chain queue, right? So that's kind of what this is, right? Copy ray tracing output to swap chain image. So that's what this is right here. We're doing a copy operation. So transition swap chain image back for presentation. So we have to put it back into the queue for presentation. And then after we present, we basically wipe the frame clean and start over. Okay, so that's in the new file. In the old file, we're doing a grand loop. This guy right here. We're looping over I, and we're doing everything at one time. See, draw command buffer is I. In the the VK CMD trace race KHR, draw command buffer is I, right? In the new one, we're just doing command buffer, right? Which is just one one situation up here. All right. So we're doing all the ray trace commands at one time, and we're just looping over them. Similar regions and all that stuff, but notice it's doing it for all of them because we have this I thing. Swap chain images I. Let's see, swap chain images I. See, swap chain images current image index. You see, so we're just doing one. Here, swap chain images I, which means we're doing it for all of the you know, for the whole lot. All right, so I've kind of made my point with that. Okay, so let's just look at what was the other stuff. We'll leave that alone. All right, so notice in our prepare function, we don't call the build command buffers in the new one because we're doing it on the fly, right? So this build command buffers is sort of your pre-building all the command buffers at once, right? Which is why it's in the prepare function. But in the new one, in the prepare function, there's no need to pre-build anything. So we remove that function. Um, we'll see where this build command buffer is. We'll see where this build command buffer is called. Um, um, all right, we have a draw call here, and we don't have it over here. All right, so see our build command buffers call here. So again, for the render call, we don't need to, in the old one for the render call, there is no build command buffer call because it was already pre-done. Okay, so it was already pre-done in this call, in this render call in the old file. In the new file, because we're doing things on the file on the fly, we call build command buffer, but we're not, this build command buffer is not for all the entire set of command buffers. It's just for the one that you need, right? Which is why it's in the render call. So in the new one, build command buffer is in the render call. In the old file, build command buffer is in prepare. All right, so that implicitly tells you that um, there's a change in sort of the logic. All right, and that's it, guys. I don't really have much else to talk about. I did a lines of code comparison between the old and new. The old had a lines of code of 920. The new one had lines of code of 906. So it's about 14 lines of code you save. But I believe it's more than 14 that we save. It's just like the formatting and stuff. Or maybe less. I don't even know. But so the lines of code doesn't really give us a hint into efficiency in this respect. But I could say that the new script is way easier to follow. It's way easier to follow because I couldn't, even with the pre-recorded command buffer stuff and like looping through I and all that stuff, it's just hard to really follow the logic, right? And even that draw command buffer variable, it's just, a lot of things are happening even outside of this file for that variable. So it was just a lot more problematic. But with the new one, things are much better. So, again, I want to thank the author for for taking the time to improve the script. We certainly appreciate it and learn from all that has been done. Yeah, and I'll dive into this some more. I can't necessarily say it will be the next video or stuff, but as time goes by, I will chip away at sort of going into the new logic and how it works, and especially the command buffer piece, because now that it's a little bit more simple and straightforward, I want to be able to really dive into the command buffer. All right, guys, thank you for watching. Have a great day.